Welcome. This video is problem 14 in lesson 2.2. You try cost, revenue, profit. February is a busy time at Charlie's Chocolate Shop. During the week before Valentine's Day, Charlie advertises his chocolates will sell for $1.80 a piece instead of the usual $2 each. The fixed costs to run the chocolate shop total $450 a week, and he estimates that each chocolate costs about 60 cents to produce. Charlie estimates that he can produce up to 3,000 chocolates in 1 week. Okay, so quick thing about how to determine the functions we're looking for here. We want to know the cost function, the revenue function, and the profit function. So the thing to know about the cost function is made up of two things. C of n has two pieces to it. There's a fixed cost and a variable cost. So C of n has got a variable cost, and that variable cost is determined by how many chocolates we make plus some sort of a fixed cost. So how do we determine the variable cost and how do we determine the fixed cost? Well, the variable cost, the way you want to think about that is that the variable cost is equal to some dollar amount, the price per item, times the number of items, which in this case is going to be given by n. So what that tells us then is that our C of n here, or our cost with respect to n, number of chocolates that we make, is going to be equal to, well, it cost him 60 cents to produce each one of the chocolates, so that's going to be 0.60 times n, which is the number of chocolates he makes, plus his fixed cost, and he says it costs him $450 a week whether he sells a single item or not, just to keep the doors open. So that's his cost with respect to n. So hopefully that makes sense. The revenue function. Now, revenue is very similar to cost in the sense that it's a dollar amount times the number that you make, but this time it's money in your pocket, not money out of your pocket. So our revenue function is equal to whatever we're going to charge per item times the number of items that we produce. Well, during Valentine's week, Charlie's selling them for $1.80 each. So that's how much it is per item times the number of items, which is equal to n. Now profit is when your revenue exceeds your cost, but the function that determines that or tells you that is given by the revenue less the cost. And when our revenue is less than the cost, the profit will be negative, which means we lost money. And then when our revenue is greater than the cost, our profit will be positive, which means we made money. When the revenue is equal to the cost, that's known as the break-even point, and that means our profit was equal to 0. Okay, but we need to give them back the profit function. To give them the profit function here, what we're going to do is come in and say, okay, see this red box right here? What's in that red box is R of n. What's in this red box is R of n, and by Jove, what is in this red box? Well, that is also R of n. So what we're going to do is dump out R of n and replace it with $1.80 n, or 1.80 times n. Okay, same idea with our cost function. So this is a cost function. By Jove, that's the same cost function, and by Jove, that's the same cost function. So all of those are the same. So what we're going to do is, again, replace C of n with its definition. But in this case, we're going to be careful and be sure and put the parentheses in there and put 0.60 n plus 450, and then close off that parentheses. Very important that you put those parentheses in, because what we're going to see here is that we're going to think about, to get rid of these parentheses, there's an unwritten -1 out front there. So that tells me that this is 1.80 n minus 0.60 n minus 450 is what our profit function is. Or simplifying this, it's 1.20 n minus 450 is our profit function. Okay, cool. So we've got our three functions, and in particular we have our profit function, is that the profit given by the number of chocolates we make is equal to $1.20, if you want to think about it that way, times the number we make minus 450. Okay, so let's see. Part D, they say interpret the meaning of the statement P of 300 equals -90. Well, let's do a little better than that. Let's go ahead and actually evaluate P of 300, and then we'll tell them what that -90 means. Well, P of 300 means that we must have made 300 chocolates, which means that that's $1.20 times 300 minus 450. Okay, so let's get our handy dandy calculator out here. Let's see, I got that on here someplace. There we go. And let's go ahead and do that. Let's take 1.2 times 300, subtract 450. And by Jove, yes, we do get negative 90. And what that means is we lost $90. We didn't make enough chocolates or sell enough chocolates to make any money. So that means we've lost $90. So we sold 300 chocolates, and our net loss was $900. That's an S there on us. Was $900. Okay, hopefully that makes sense. Okay, determine the practical domain and range for P of n and use that information to define an appropriate viewing window for the graph of P of n. Sketch the graph using the space below from your calculator. Okay, so practical domain. So let's go back to the previous slide here. What do we know? Well, we know that Charlie can make no chocolates. He can't make any negative ones. That wouldn't make any sense. But he says he can make up to 3,000 chocolates in 1 week. Okay, so the right page here. So that tells us that our practical domain is he can make no chocolates up to he can make 3,000 chocolates in 1 week, and that's as many as he thinks he can get by. I mean, after that, he does have to sleep and have a life and all the other things, right? Okay, so how do we find the practical range? Well, to find the practical range, what we're going to do is we're going to figure out, again, we back up just a moment here. We're talking about P of n, the profit function, the practical domain, and the range for the profit function here. The domain makes sense just based upon what they gave us in the problem statement, but how do we figure out the practical range on the profit? Well, we're going to take the endpoints from our domain here. We're just going to take these two numbers, the 3,000 and the 0, and we're going to plug those into P of n, and they're going to give us the practical range values. So if we let n be equal to 0, then that says we're looking at P of 0, which is going to be equal to 1.20 times 0 minus 450, which is going to be equal to negative 450. So, I mean, that makes sense. It says that if Charlie doesn't sell any chocolates at all, it still costs him $450 just to have the place to have his business. So that's the lower end of our range. So I've got to put a P of n in there. Don't put an n. We're talking about P's now. Now what about the upper end of our range? Well, that would happen if Charlie sold all 3,000 of his chocolates. If he sold out. So I got to go home early because I had no chocolates left. In other words, he let n be equal to 3,000. Then we want to go find P of 3,000, which is going to be equal to 1.2 times 3,000 minus 450. Okay, so let's go ahead and do that on our calculator here. So 1.2 times 3,000, subtract 450, and we get $3,150. That's the most that he can make in a week if he sells out of all of his chocolates. So 3,150. Okay, so we're going to use these numbers to help us find our sketch of our graph. In other words, we're going to use these as our window settings. So if we go back over to the calculator here, and we go to the window, we're going to go ahead and start at 0, and then we're going to go to 3,000 for x max. So x min is 0, x max is 3,000. Now you could leave your x scale to 1 if you'd like. I made it 500 because I don't like having that many tick marks on there. And then my y min, well, that's the negative 450 is the worst profit we can possibly make, right? So that's negative 450. And then our y max would be 3,150. That's the most profit we can make in a week. And our y scale, again, I'm going to make that 500 just so I don't have a bull-faced y-axis. Okay, now press graph, and you should get the following. Now, if you happen to be working on an iPhone, press graph, and then your window settings can be adjusted in the graph, or you can do it before you press graph. Okay. So we want us to make a sketch of this onto our homework sheet. So let's go ahead and do that. So we've got our y-axis here, which is actually being played by P, and then there is our n-axis right there. And then we have our line that looks not quite unlike, but similar to that, okay? And that line right there that's our P of n line. So that's P of n equals to 1.20 n, minus 450. Of course, I used an x on the calculator because got to have that in there, right? Let me back up for just a minute. I did skip a step there. I forgot to show you that I actually entered that into my y equals menu here. So you got to put the 1.2x minus 450 into y1 in order to be able to get that graph going there. Sorry about that. I should have mentioned that before I actually did the windows, but you know. Okay, so let's come over here. Let's do a little labeling of our axes. That is always a good thing to do. So this is n. This is P of n. That's our vertical axis. This runs from negative 450 to 3150. And this runs from 0 to 3000. That's making a pretty graph. Okay, so how many chocolates must Charlie make to make break even? Well, as we said at the beginning here, is that the break even point is where profit is equal to 0, which means your cost is equal to your revenue. So when your cost equals your revenue, then that infers to you that your profit is equal to 0. In other words, think about it. What did we get? We had R minus C. That's what P was equal to. So if those two are the same, we take the difference from them and I'm going to get back out equals 0. All right. So let's go ahead and use that information and take our profit function, which is 1.20n minus 450, and let's set that equal to 0 so we can figure out exactly what our break-even point is. In other words, how many chocolates do I need to sell so I don't lose any money, but I didn't make any money? So that's 1.20n is equal to 450, or n is equal to 450 divided by 1.20, okay, or 1.2. So let's go ahead, go back to the calculator here, and let's go ahead and take 450 and let's divide that by 1.2. We get 375, which makes sense because we didn't really lost money when we only sold 300 of them. So the break-even point here is going to be 375 by 0. In other words, you got profit of 0. They asked us to mark that on there. Well, hopefully you found this helpful. If there are any additional questions about this problem, please do not be shy about posting to the Q&A forum.